Today's goal is to review the statistics units, statistical design and statistical inference. Keep in mind, statistical design is about designing a study that we can use to gather data. Data we can then use to form a statistic. A statistic is usually a mean, an average, or a proportion, a percentage, that comes from a sample, a small group of people from your population. Okay? Statistical inferences is about what can we infer, or what conclusions can we draw from the small group of people that we spoke to, then about the larger group, the population. First question. Keep in mind, you don't need to copy these questions word for word, but you should summarize them in your notes so that your answers are meaningful. Question 1. The bodega owner by the park decides to conduct a study to determine whether students are more likely to consume bacon, egg, and cheese bagels or vegetarian breakfast sandwiches. Okay, this is about choices. He keeps a tally of every student that enters the bodega that morning. Name the population. Well, he'd like to know information about students in general. So my population would be all students, or all students that shop at his store. Using the language right from the question, we can just say generally, students. Okay, sample. That's the people that he's actually getting information from. So he's telling every student that enters the bodega that morning. Again, using exactly the language from the question, we can say the sample is every student that enters the bodega that morning. Okay, the sample. We just said parameter of interest. So I'm interested in something. It's implied that we're sort of interested in one of these two choices. So a parameter, much like a statistic, will be a mean or a proportion. And since people are picking between one of these two options, we'll be able to calculate the percent or the proportion of all students. Proportion, the parameter, comes from my population. So the parameter of interest is the proportion of all students who prefer, we get to pick one here, the proportion of all students who prefer bacon, egg, and cheese, bagels, to vegetarian breakfast sandwiches. Now, this question didn't ask us for a statistic, but if it had, the statistic really closely mirrors the parameter. Both would have to be proportions, but statistic, instead of being about all students coming from the population, the statistic would be the proportion of students who entered the bodega that morning This should look familiar because this is exactly our sample. So the proportion of students who entered the bodega that morning who prefer bacon, egg, and cheese bagels to vegetarian breakfast sandwiches. Notice that the parameter and the statistic are very similar. Both are proportions. Both are about preferring bacon, egg, and cheese over vegetarian. The difference is that the statistic comes from your sample, whereas the parameter comes from all students. The parameter comes from your population. Okay, part B. How does the statistic differ from the parameter of interest? We just spoke to this. The statistic can be calculated using data gathered from the sample group. This guy is actually tallying students who bought vegetarian, who bought bacon, egg, and cheese. And he's tallying it, so he will actually be able to tell this number. Whereas the parameter can be estimated rather than calculated because the parameter is the proportion of all students who prefer bacon, egg, and cheese to vegetarian breakfast sandwiches. But we don't have information about all students' preferences. That is, we will actually be able to calculate the statistic because we will know for some students in the sample what they actually picked. The parameter we'll say is probably similar to the statistic, but we don't actually have information from all students. Okay, question 2. Identify which type of study is illustrated by each example. Identify how the sample was selected from the population and explain your reasoning. Okay, in A, to determine the effectiveness of a new advertising campaign, a restaurant asked every 10th customer if they had seen an advertisement and if it had influenced their decision to visit the restaurant. Okay, so it's asking for 2 things. We need to know the type of study. We need to know the sample group. Okay, types of studies, there are 3 options. We've learned about surveys. We've learned about observational studies. And we've learned about experiments. So these are your 3 types of studies you have to choose from. In this case, they're asking. It sounds like it's going to be a survey, except they want to see if there's an influence, right? They want to see if there's a relationship between the advertisement and a decision to go to the restaurant. Maybe they saw the ad and everyone looked like the food was really good or everyone was having fun. Or maybe they saw the ad and the food looked not that great, but they still decided to come. Maybe there's a relationship, maybe there's not. Since even though they're asking a question to get the data, because they're trying to look for a relationship, this would be an observational study. Okay, so we know what type of study it is and we need to know how the sample was selected. The sample was every 10th customer, every 10th person that walked into the door. This is called a systematic sample because you have a system for deciding who you'll ask. You skip the first customer, the second, the third, fourth, fifth, sixth, seventh, eighth, and ninth. The 10th one is the one you ask. Skip 11, 12, 13 through 19. The 20th is the one you ask. There's a system there. It's not the most random way to choose a sample, but it's fairly random. It's okay if you don't have another strategy available. Like you wouldn't have a roster of all customers because you don't know who's coming in. So you cannot use a random number table in 2A. Okay, 2B. To determine if higher speed limits cause more traffic fatalities, researchers compared the number of traffic deaths on randomly selected stretches of highways with 65 mph speed limits to the number of traffic deaths on an equal number of randomly selected stretches of highway with 75 mph speed limits. Okay, we need to know what type of study this is and what the sample is. In this case, they're using numbers of traffic deaths. This is data that already exists. This is historical data. And it appears that they're doing that on different limits to see if there's a relationship between number of deaths and how quickly people were allowed to travel. Again, a relationship makes this an observational study. It's not an experiment because you're not imposing a condition on someone. You're not telling people how quickly they should go. The speed limit is there, and then people, of course, make up their mind. So it wouldn't be an experiment, and it's not a survey because it's not simply asking with the goal of stating a statistic. Okay, then we need a sample, and in this case, it just says they randomly selected stretches of highway. We assume that means they either flipped a coin or drew names out of a hat or probably used a random number table. But the sample in this case is some sort of method to randomly select stretches of highway. Okay. Question 3. Design a means of obtaining a data. That sounds like we're designing a study to determine whether living in an urban area affects the health of pregnant women and their newborns. All right, we know that if we're designing a study, we need to do 3 things. The first thing we need to do is choose a sample. Who's going to participate in this study? Well, we would have to have people that we have data about, right? And so maybe we make a list of doctors who are willing to participate and number them. For example, we don't know how many people are willing to participate. So maybe we'll number them from 001 to, let's say, 250. Maybe we have 250 doctors willing to participate. Then we want to make this really random. Systematic is okay, but random number table is always best. Use a random number table to select 3-digit numbers. Since each person would have a 3-digit number associated with them, we're picking 3-digit numbers between 001 and 250, excluding repeat numbers, and of course excluding numbers that are outside of this range. Select, I don't know, maybe we want 20 participants. And match the numbers circled or the numbers selected to the doctor's names. Okay, now we have a list of doctors who are participating. We will use data from, let's say, each of their patients. This is about health of pregnant women and their newborns. So we would have to have patients who recently gave birth. Let's say each of their patients who gave birth in the last 12 months. You get to pick some of this. Maybe you're saying in the last 6 months or the last 2 years or whatever. You get to make some of these choices yourself. All right, we have a sample of people that we're going to get information on. Now we need to make a plan to obtain data. We need to get numbers. Okay, so we want to know information about the health of pregnant women and their newborns and if this relates to their area, like where they live. So for each patient, we need to know about where they live. Ask, do you live in an urban, suburban, or rural environment? I don't think there's any need to ask other questions. I don't think they will feel like they need to answer in a certain way. No one place is better than another. There's no stigma attached to living in a certain place. So I think we can just be upfront. Which place do you live in? Now we also need information about their health and the health of their newborns. There are different ways to measure how healthy a baby is. One way to measure how healthy a baby is to look up its weight. So we can then ask doctors to write down for us or record the baby's weight at birth. Maybe you want to use a bunch of other metrics as well, but this is one quick and easy way to get information on how healthy they are, right? If a baby is born at 4 pounds, that is too light. If a baby is born at 12 pounds, it's a really heavy baby. Okay, final thing we need to do is make a plan to analyze data. So we can say separate each patient by where they live and calculate the average birth weight of babies born in urban, suburban, and rural areas. If you find out that babies born in cities weigh 3 pounds on average less than babies born in rural areas, maybe that's an indicator that it's healthier to be pregnant in a rural area. Maybe you find that the average weight is very similar, and so maybe there isn't a huge effect on the location where you live and one measure of healthiness.